People will come from all over the world, and when they see him, they won't laugh. They'll salute.
And a salute to the most frequent command that we are going to use in our, it's time for us to do regression. It uses the lm command for linear model, and often when we use this command, we want to store it in a box. And the guy who taught me how to do this called that box fit, because the guy who taught him called it fit. So fit is the name that has some tradition behind it. And along with this command, we also want to use summary of fit, because this is the command that does the work. This is the command that will show us the good stuff about what's been done. Obviously, the banana data set we were just looking at isn't going to work because it's not a straight line. So I'm going to sweep and clean everything. Control L to clear that. And let's start with a new data set by the name of Old Faithful, which is one of my favorite data sets because it has how long until the next Old Faithful eruption, predicted by how long the last eruption lasted for. This is really important because if you've ever been to Old Faithful with kids, they're all like, how long do we have to wait? Just be patient. So can we tell them how long we have to wait so that they don't keep whining and asking? Children's lives are at stake here. Grab the URL. I'm going to call it Faith instead of Faithful because now it's fewer letters. Read in the data set. Yes, it has a header. And I want to just check that it read incorrectly. Looks like it did. The next thing I would want to do is to try to plot interval based off duration, data equals faith. Always let your brain take a little look at it. It looks like the longer the last eruption was, the longer it's going to take for it to erupt again, which makes sense, considering it takes time to build up that pressure from the supervolcano that is secretly going to kill us all. Let's move on. Fit, linear model, interval based off duration, data equals faith. Notice that my command here for the linear model looks almost exactly like the plot command, except I changed plot for lm. That's on purpose. That's one reason I looked at the picture this way. When I run this, it doesn't show me anything, but it made a box over here called fit. That fit box is full of all sorts of regression information. If I just say fit and I run that to say what's in there, the only thing I'm going to get is the slope and the y-intercept, which isn't a lot of information there. For some reason, when they programmed R, they decided that running just the LM would only give you the bare minimum of what you might need. So the command that's going to help us is the summary command. If you use summary on a data set, it'll tell you like min, max, and average, things like that. If you use summary on a box full of regression things, then it says, I'll bet you wanted to know all sorts of information about that regression. So this output right here is full of good stuff. Right here it tells you what you ran. Here's some information about residuals. We'll talk more about that later. And here we have the y-intercept and the slope. That slope is critical because the question is, can I predict the interval based off the duration? And the p-value here is almost 0. This is scientific notation for 2 times 10 to the negative 16. So if I wrote that out, I'm going to need to move that decimal point 15 times, which means I'll have 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 1, 6. That's what this number is. So pretty close to 0. It actually says less than that. So essentially the p-value is super tiny. Small p-value, reject the null. The null said there was no relationship here. We reject that. Yes, there's a relationship. Well, looking at the picture, I could tell that. That's great. How much is the relationship? It's 10.7. In other words, if you want to predict when Old Faithful will erupt, you take how long the eruption was before, times it by 10.74, add on an extra 33.82, and that's how many minutes you have to wait. An hour sometimes, looks like up to an hour and a half sometimes. This number down here, that is the error of the data, how spread out the data is. Notice that if I had more data, this number might get a little more accurate, but it wouldn't disappear. It wouldn't go to 0. It's about 6-ish is how far the data spreads from what you might predict. Over here we have another error, but this is how much error is in the slope. If you get more and more data, you'll have less error in the slope. So this number actually will drop to 0. But that's not really important. What's really important is knowing whether the slope is significant. That's this p-value here. And this number says how accurate your predictions are going to be. They'll be off by about 6.6. And down here we have r squared, which we've talked about a little bit, but essentially the closer it is to 1, the more that your data is easily predictable. 0.73 is not bad. That's actually really good, which is why Old Faithful is so famous. So out of all this output, what should you most be interested in? You should be looking at this number because it's the y-intercept, and I just covered over part of it with the pen. You should be looking at this number because that's your slope. This p-value for the slope tells you whether x and y have a relationship. Here we have the accuracy of our predictions, and here we have our r squared. At some point, we'll talk about this adjusted r squared, but not yet. So right now, there's the 5 different numbers that should be really of interest to you.